Thank you, Darius. Good afternoon, or good morning, or good evening, whichever applies to you. Thanks for taking the time today to join this webinar. We're going to start out with a short set of slides, mainly to provide you with a framework for the remaining portion, which will be live demonstration in our software. So we'll just spend a few minutes here on a few slides. So what we're going to be talking about today, as the title mentioned by Darius, is the ability to apply the Altair HyperWorks tools to do CAE and predictive analysis for the disciplines of vehicle dynamics, which also includes suspension modeling, as well as durability or loads generation. So we're going to take a few minutes to talk about what does that mean and what do you get from that and why would one perform these assessments. And then just briefly show you the big picture of the HyperWorks suite and zoom in on the particular products that we'll be using throughout today's example. And then we'll go through a live demonstration, which will start out with an introduction to the environment so that you can be oriented on how the look, feel, and workflow applies. And then we'll dig deeper into suspension, vehicle dynamics, and durability and loads modeling from there. So let's start off with a little bit of overview of the typical analysis types that are done in automotive. The suspension analysis is a study of typically a front or a rear suspension and its characteristics. We'll go into that more in just a minute. Then there's also full vehicle dynamics simulation, where you study a vehicle as it behaves on an actual road surface. And then finally, there's using the capability within the tools to actually understand internal loads that are happening through a system and to be able to apply those to a process which can give predictive capability for the lifespan of certain components, and that's called durability and specifically loads generation. So let's go a little bit deeper in the area of suspension analysis, the category of vehicle dynamics, but it's really the first level that's studied, and in fact, when on, you can learn a tremendous amount about how your system is going to behave, even well before you go into modeling full vehicle. So, as I mentioned, it's modeling and of an entire front half of a rear half of a vehicle. In how that behaves. What we're going to see here is that when I first introduce you to the environment, that there's so it allows you to perform and select several existing suspension topologies on the front, built in to look at all the results, and the specs of the reports are called SDFs, or stands for suspension design factors, and these are kind of your scalar quantifiers of how a suspension is behaving. And then I won't go in a lot of detail today, but there's also a particular product called HyperStudy, which will allow you to take all of what I'm going to show and go one level farther and perform studies like design of experiments and optimization around a nominal working model. So that's the introduction to the suspension side. For full vehicle, this is where you now want to simulate an entire vehicle on road. And again, this same built-in automotive library has many different full vehicle analysis tasks that you can run and has associated reports with those for interpretation. And this is all done through these wizards that you'll see. And again, those reports will allow you to animate and view resulting plots for all the different types of analysis that you run. And so then you can compare designs and overlay those. And then on the durability or loads generation front, that typically breaks down into two different types. There's the semi-analytical durability, which is really where you model a vehicle sitting on a four-poster machine. So in that regard, what you're basically doing is kind of bypassing the tire physics, and you're using some information about the wheel center vertical motion, and you're driving the system with that and getting the response. So it's something you can actually do in a laboratory. And then you can, again, acquire these internal loads and pass those down to a fatigue type solver. Then there's the full analytical durability, where you actually include a high-end tire model. And Altair supports 3 of the world-leading high-end 3D tire models. So you have F-Tire from Cosin, CD Tire from Fraunhofer, and R-Mod K-Tire from T-Systems. And these are models which will take into account the full shape of the surface as far as vertical distribution, whether it be a bump like the middle picture or Belgian block or the like, these high-end tire models. Now these do have to be purchased separately, but from an infrastructure standpoint, they've all been very well developed and tested with the software that we're going to show today. So just a brief picture of how the loads generation applies, since we're talking about durability in this section. The load results, the bottom box, is the key piece that comes from the analysis that we're talking about today, the multibody dynamics analysis. In addition, you pass in material data or results of understanding how stress per unit load is generated on a component, and together that can go into a tool that does fatigue prediction. For example, in Altair's suite, there's several partner programs that leverage the Altair licensing system. One of those is the ENCODE Design Life product, and that's a fatigue prediction based off the information that would come from the analyses like we're going to show today. And just the point here is that whether it be semi-analytical or fully analytical for durability, the idea is to emulate real world as best as possible so that you can get these accurate loads that represent how the system would work in real life. So then, to finish up the slides, I want to give you a brief introduction to the solution set and which of those products that we're going to be talking about today. On the solver side, which is, you can think of it as the real big calculator that takes all of the system information and performs the calculations to produce all of those signals, there's an entire suite: OptiStruct, Radios, MotionSolve, AccuSolve, Phaco, VizSim, and again, several of these partner products that work off of our licensing. And these overall cover really the full domain of CAE, mechanical, electrical, fluids, you name it. But what we're going to focus on from a solver standpoint today is this third from the left, MotionSolve, because all of the analyses that we're discussing, suspension design, vehicle dynamics, and durability, are being solved by a multibody dynamic solver. We call that MotionSolve. From a pre-post or modeling visualization standpoint, again, there's a full range of products. HyperMesh, something many of you may have heard of, is kind of a flagship product for finite element analysis. HyperView for animations, HyperGraph for plotting. We're going to be using those a lot. And then the primary preprocessor for multibody dynamics is MotionView. So primarily today we're going to be using MotionSolve with a few times that we'll step into HyperView and HyperGraph when we want to do results visualization. So that's kind of the overall framework. And what I really want to spend the rest of the time on is the actual product. So what I basically have here is the MotionView product. Again, MotionView is the preprocessor, with the solver being MotionSolve. And I'll start out, I just want to give a few-minute introduction of the environment. I'm sure there are people who have not seen this environment before, so let's take 5 minutes to see what this looks like. Basically, when the product opens, you see that I have what's called one page, and on that page I have one window, which is actually set to be the MotionView preprocessing window. And you actually, in this, can have multiple pages, and in those pages you can have multiple windows. For example, here I might split this to be 3 windows. And maybe I'll keep the first one as the pre-processing window. Maybe the second one, I'll go down to this selection area here and I'll make that a plotting window, for example. And in the third one, maybe I'll pick from a variety of others. Again, a common one we're going to use today is HyperView, which is for animations. And again, I can have multiple pages. So that's page one, as I can look here in my session browser and see that on page one I have a MotionView window and a HyperGraph window and a HyperView window. But I can add a whole nother page and again turn that into a layout that I would like. Let's say maybe I want to do a bunch of plots. So I can change the window to that, and basically, well, let me add another page here. And in this case, I'm going to change first to the plot, so that way it carries all the same layout type, and I get a bunch of plots. So you have the full control over this array of pages. What typically ends up being the use here is you have one pre-processing window on one page, and then you'll have another page that you typically use for your animations, for HyperView, and then many plots spread over a bunch of other pages. And you'll see that when we get a little deeper into the reports in the demo. So as with many codes, you have your menus across the top, your various toolbars for visual and quick access to certain features, and then down here we have a toolbar set that is dependent on which window type you're in. So if I go back to MotionView, this bottom toolbar changes to everything involved in the pre-processing. If I go to HyperView, this toolbar changes to all the visualization options for your animation, and then HyperGraph, again, it's the toolboxes for all of the plotting. So what I'm going to do is go and just do a file new. You'll see me do this a few times in the demo. It kind of does a full reset, so I can kind of get back to square one. Also, you'll see here there's a couple different browsers. That session browser I already showed you briefly, which gives you the big picture layout of all of your pages and all of your windows and what types they are, and you get a few other little controls in there. But then also the project tab is the one that's a function of your active window. So again, if I go here to switch over and I make my second window a HyperGraph window, then you'll see that this is now called the plot tab, and that's kind of the browser for controlling the plot. But if I was to have made this, or if I go back over to a window for MotionView, then you see that you have the tab that's a function of that. So this toolbar down towards the bottom, as well as the browser, tends to update based on which window you have active and that you're working in. And so that's really the big picture of this overall framework, that the MotionView window, as well as HyperView, 2D and 3D plotting, HyperMesh as well, and even some additional capabilities like table views and text views are all optional window types in there. So let me do, again, a clean refresh. And at this point, what I'm going to do is start to go down to give a little more detail on the actual automotive applications that we're talking about today. So if you recall, we're going to do suspension, and then we'll get into full vehicle dynamics, and then we'll get into some durability and loads generation. So let's start out with the suspension side. Now, even though this pre-processing window does give you full control at what we sometimes call an atomic level, you can add bodies and points and forces and joints all day long, it would take a long time to have to create all of your suspensions by scratch. So in addition to this general environment that you see here, for no extra cost, no extra units, there's an entire vertical library dedicated to suspension and vehicle dynamics and durability modeling built in. And those are accessible up through the top menu, through this model and this analysis tab. So what I'm going to do is start out and bring up this assembly wizard. And you'll notice the choices here are, again, giving me access to this built-in library of a set of topologies and some default data. You can always set your own data, of course, and then you can load and save your own data, and you can even modify the topology on the fly if you needed to. But right now we'll work with kind of the defaults. It'll make the demonstration kind of flow easy, and then I'll make some modifications after that. So I can pick that I want to work on a front suspension or a rear suspension, and then later on we'll get into the full vehicle stuff. So let's say I want to do suspension modeling, and I go and say, okay, I'm going to do a front, and do, say, no drive line. And it gives me a few choices that I can actually answer right up front before it assembles the overall system. So a big one being what type of suspension. So we have McPherson strut and SLA and multi-link in the front. If I go back a couple and select rear, you'll see even more choices there where you get into many different, different topologies that are available. Quadrilinks, solid axles, 1 and 2 piece, SLAs, multi-link, a couple different permutations of multi-link, trailing arm suspension, twist beam suspension. So those are all available for that. I'm going to go back to the front and walk through the wizard a little farther on that. There's some other choices you can make, like do you want a steering system included and which topology? Rack and pinion is a common one, but in some of the overall models you'll find the different topology that you might want to use, like the parallel steering. We'll leave the simple powertrain out. In this case, excuse me, I can go ahead and include a front subframe or not. So there's these various choices. Steering boost, do I want to capture stabilizer bars or none? I'll just leave with the default. I can do jumps and rebound bumpers. Again, I can go back and add these later if I miss them. So I'm going to take some defaults, and what you're going to see is that it takes those answers that I supplied on that wizard and it goes into the big library and extracts the various systems and subsystems that I asked for. In fact, what you'll see now on the left, since I have a model instantiated in the pre-processing window, is it actually built up a hierarchical model. So this is one of the abilities that comes with this modeling environment, in addition to just the automated build of the topology originally, is kind of the whole layout and modular approach to it. So these blue areas, these are called systems, and they're containers for all of the collection of atomic entities as well as other systems, and hence the hierarchy of the model. But we do that kind of for you when you select from the library. And at this point, I have this default McPherson strut suspension sitting there. It's kind of automatically grounded, and I need to tell the code that I want to do something with this. Now, I mentioned earlier that for suspension modeling, quantifying how the suspension behaves, as it's basically kind of grounded, is real informative about your overall design, even before you start running full vehicle events. And a very common analysis to understand that data is called kinematics and compliance, which effectively is taking and putting at the tire contact patch where it meets the ground. It's putting in forces. You could think of longitudinal, lateral, rotating, overturning. Think of the 6 different directions. So vertically, it's going to put in a displacement. In the other 5 directions, it's going to put in a forces and torques, and then you can look at the results of how this exact one behaves. So here's what we're going to do. I'm going to show you the workflow to add the KNC, again, kinematics and compliance analysis, to run that and view the results, and then we're going to make a design change and overlay the new results and show you a little bit about how that works. So again, right now I have this particular topology. I could go in here and change my default numbers if I wanted to, but right now I'll start with the default. I'm going to go into this analysis task wizard, and the default is this KNC analysis. I can also cherry pick any individual sub-analyses that make that up, but the KNC is kind of like the full picture. So I will select that. It brings in all of the additional topology or mechanical elements needed to make that analysis be feasible. And then I'm basically going to go over and run the model. So what this is doing is all of this information, which is described by simplified bodies and joints and forces and motions, it's going to take that and map it out to a file that MotionSolve knows how to read. And so I'm going to give it a file name there, and I'll just call it test. And when I run that, it's going to write out that file, and it's going to invoke that MotionSolve solver. Very typical process in the CAE industry is this pre-processing solve post-processing workflow. So now what it's doing is mathematically it's walking through time, and this model has had a input description that says, okay, for 5 seconds I want you to push up and down on the wheels, and for another 5 seconds I want you to laterally push inward, and on and on and on, and builds all those different responses based off of the prescribed input. So in this particular case, it's a what's called a quasi-statics simulation. So when you run a multi-body dynamics model, you can run fully dynamic models where masses and inertias and velocities make a big effect, or in cases where it applies, and suspension modeling is really the lead case, you can have the solution be a little simpler by running a static analysis just subsequently and have various things like the input values be a function of time, and then you just run a sequence of static runs. That's called a quasi-static simulation, and that's what we just did here. It was all built in from the library. All right, so the model ran, and now I want to take a look at the results. And this is where this library and all the automation that comes with it saves egads of time here. So I'm going to go back over here under analysis, and there's something called view reports. And it brings up a log of previous simulations that I did. And I just did this K&C run here. So I'm going to tell it to please build me an entire report based off of the results of that run. Basically, MotionSolve runs, creates a set of output files that the post-processing, HyperView and HyperGraph, know how to read. And so at this time, it's basically accessing a report that's also in our library that says, hey, I want you to build me this many pages with this many plots. And in this case, you actually end up, if you can see it here, that there's actually 40 pages now in this session. So I'm currently on page 2. Page 1 is just the model window. And now you'll see these plots of the suspension characteristics. And these are things you can find in SAE papers, you can read about in our documentation, and that gets into things like your toe, caster, camber, wheel displacements, laterally, longitudinal. It's basically the kinematics assessment of the suspension as the wheels had moved up and down, but also as a function of those other 5 directions of loads and torques. So you can walk through and see all these different ones. Now, I'm not going to go into great detail of which ones are there today. Those are documented, but you'll see a glimpse of it when I go show you the final page of the report that's generated. So I'm going to jump down here, and well, actually, there's 2. First, I'm going to show you the animation, so you can see what this looks like. It's going up, and then while it does that, I'm going to go ahead and put on and ask it to visualize some force results. And so this is, again, this is that HyperView window. We also call it the animation window, and this lets you see the time history of how your overall responses are in 3D space. And then you can also see some of the applied forces, and you can go in and recover additional forces. And then the last page in the report, this is probably the most powerful for suspension analysis, is called the SDF report. And this shows over 90 measures for each and every position of the wheel. So at time 0, we had a 0 position, and it gives you all of these. Again, these are those scalar values that describe the overall system. There's a ton of them. Every one of them is documented, including how it's calculated and what it means. And you have everything from your Ackerman angles, your anti-lift, anti-dive, all of the classic characteristics, and it does it for each time step. So at 0.1 seconds, it was up at 6 millimeters. And at the next step, at 0.2 seconds, it was at 12 millimeters. So you actually get an array of these results sets. And this is very powerful and gives you a lot of information about how a suspension is behaving. Now, suppose I've run that and I got my results, and now I want to make a little design change and compare the results. So what I'm going to do here is just zoom. I can do it a couple ways. I'm going to make a geometry change in this case. I could change bushing rates. I could, change numerical values, but in this case, I will go to a particular location. So this is this lower control arm, and I can change it here, but if I want to get a little bit larger glimpse, I can actually go to this model data summary, and that gives me the entire view of all of the numerical values in the whole model, starting with the points table. So I can also go down here and just locate the front McPherson suspension, lower control arm bushing. So either way. So I'll go in here, and the original default was 911 millimeters, and I'm going to up that to 920. Okay, and then we're just going to do another iteration. So let me take this and call it test 2. And I'm going to run that. Just take another half a minute here. So what I've done is made a design change. I'm asking the solver to take that into account and produce a new set of results. And then what I'm going to do is run that report again, and I'm going to run it in a way where I get to compare the old results and the new results. So this just takes another half a minute for MotionSolve to do its overall calculations. You'll see when it's finished, because MotionSolve, which is echoing this information, will give us some description that the run is complete here as soon as it's done crunching all the numbers. There it goes. Everything's good. Okay, so now I've made that design change. I go back up to View Reports, and I select the newest simulation. And here I'm going to tell it to not auto color plots because I want them to be different. And I'm going to do an overlay. So what it's doing is it's taking that same report, it's keeping the original data, it's now applying the new data, and then I should be able to see a run 1 versus run 2 type of analysis, as you can see there. So you have the red and the blue line, and as you walk through, you see all those. Now you can do this as many times as you want. You can build up a whole array of lines if you need to, and if I want to turn certain iterations off, I can just go here to this layers button and actually turn entire layers off. So maybe I have 50 different design iterations with 50 different lines. Obviously that would be confusing to look at, but I can go into this layers and just turn on certain results. Of course you can name things a little bit more, to describe exactly the run that you made. So from a suspension modeling standpoint, in summary of that part, you can build up, go back to the page 1. You can build these topologies right out of the library. If there's a topology that you are working with that's not supported, there's a few different options. You can start with one from the library and modify it. You could build one from scratch. If you really become a MotionView champion, you can actually go in and add a new topology to the library. You have to build it up, and then you just add it to the library and have that as a choice. Excuse me, or even build your own library, because it's completely extensible and open. And that's a key component of actually all of Altair software, especially with MotionView and Hypergraph and HyperView, is a lot of very open architecture for you to be able to expand it. So you're not just stuck with just the suspension topologies that are in the library. I can go right in here and start to modify these. I can delete them and add more or whatever. So that is, in a nutshell, the summary on the suspension modeling, at least using the library and the automated tool. I wasn't going to go a lot today into what I call the atomic modeling, but just know that every one of those entities in your entire model you can work with individually, delete them, add new ones, whatever. You can even load and save entire subsystems to your heart's content. So that's a brief introduction on the suspension side. Now what I want to do is go and talk about the full vehicle side. So I'm going to do that new session again and bring up the library, because we're going to leverage that automated library again. And here I'm going to say full vehicle. There's actually two different ones. There's the full vehicle, which has a, let's say, a level of driver that's needed to run all of the full vehicle analyses that we have. I'll show you what those are. And then in the release that is actually coming up here in a matter of days, called 14.0, we actually have introduced a new driver, and I'll show you that as well and what that offers. But let me go with the traditional full vehicle, and it wants to have some form of a drive line. Again, you have these selections again about the types of suspensions and topologies. It's all the same set as before. So here I can build a full vehicle that is a combination of any front or rear that's in the library. And by default, it's going to pick the handling tire, which is the MF tire. That's the magic formula from Pajeca. Most of you are probably aware of that. Very good tire model. We have a lot of example input files for the tire, and then this library uses that out of the box. Similar choices as before as far as some of the details of the suspension, so I'll just bypass those and get a vehicle model in the library, or out of the library into the window session. So I have a full vehicle. Again, this is with default data. Of course, you go in, you're meant to, and modify anything to your own values. So I can go in here, bring data summary, and start to adjust values as needed to match what you're studying. Now, again, as with the suspension, it was built, but there also needs to be an analysis added to actuate that. So here, it knows I have a full vehicle, so if I go back to my analysis task wizard, you'll see a bunch of full vehicle analyses. So you have single lane change, double lane change, constant radius, throttle off, cornering, throttle on, steer release, braking in a turn, sinusoidal steering. The list is actually quite big. And what I'm going to do is pick a single lane change analysis. And similarly to the suspension side, this appends the model with all of the mechanisms and access to driver models and things needed to have this. And one of those is a pointer to the tire file and a pointer to the road file. In this case, it's just a flat road data file and a Pajeca magic formula tire file. But this is set up to be able to do a lane change maneuver. So I'm going to go ahead and run that, and I'll just keep reusing that test name. Same as before, it's taking this entire system and all the suspension and the information for the drivers, it sends it out to a file that MotionSolve reads. That's all behind the scenes. Basically what you see is MotionSolve running. And after a few seconds, the simulation will finish, and then we'll go ahead and take a look at the report for this one. All right. So again, go back to my view reports. Here I have the single lane change run that I just did. Overlay, I'll do auto color since it's the first run. And there I have the results. So in this one I got 3 pages. Obviously the first page is just the model page, so it appended 2 pages. And I have the plotting and the animation page. So we can take a look at this. Let me slow this one down a little bit so you get a good look at it. All right, so there it goes, and then right at the lane change, I'll slow way down. So what this is doing is actually putting, we have a full steering system in there, so it's putting in the information needed to the steering wheel in order to hold this path. Most of the analyses in this full vehicle library are open loop, but this is a case of more of a closed loop one, where there's a little bit of a controller built in to keep it on path. And if I step back over to the plots, you actually see measures like roll angle, yaw rate, very typical full vehicle type measures that you want to access. So again, with the automated library, the idea is to have the software do the work for you, so you don't have to build so many things up one at a time from scratch. Now, let me go over and pause that animation. I'm going to clear the session out, and I want to show you the other full vehicle, because if I got to switch over to MotionView because I had reset it while HyperView was active. And here I'm going to build up a model, and in this case I'm going to pick that new feature that we have in 14, which is a full vehicle with an advanced driver. Now this driver allows you to, instead of just defining one event like drive straight for this long or do a turn at this time, it actually lets you access something called the Altair driver file, which I'll show you in a minute. And this is really free form. It lets you do things like run for 2 seconds. And then at that point, whatever the state of the vehicle is, I want you to do a sharp turn. And then maybe you do that for 4 seconds. and then you want to do a sharp turn back. So it's actually kind of an open-ended definition, and it's also a very, very good path controller. So let's say you had a track that you wanted to have your vehicle follow. For Formula SAE, for example, you can define a road and the center line for that track, and this has full controller built into it, and it'll stay on that track. And one of the main differences too is that this full vehicle with advanced driver actually introduces a powertrain, brake, and driveline model, so that you can have gear shifting, throttle, brake taken into account, and you can tell it if you want to shift, or it can do it automatically, all kinds of things. So all you do is pick that, and again, similar type of thing, except here you start to see those other things show up, like the information for the powertrain and some of the signal information needed. The rest of the defaults are similar, although there's that there's a little bit more of a brake model and driveline. So I'll build that model in this case under the context of the advanced driver. The vehicle's going to appear the same, but if you look over here, again, here now I got a disc brake system, I got my signal, all my signal things that are needed for the controller to work, I got my powertrain. But as similarly as with the other case, now I have to add an analysis. And in this case, it adds just the one. It basically says the Altair Advanced Driver Analysis. And what this says is I'm going to use a driver file to define the details. So as opposed to kind of a hard-coded steer this way, brake this way, it says I'm going to use the driver file. So if I pick that over here, see how it appended this Altair Advanced Driver Analysis? It's effectively a pointer to this ADF file. And to give you an idea what that looks like, there's a very common format, a very human-readable and human-editable format called Team Orbit, which is what is used here. It's kind of got these little blocks with information in it. And we have this fully documented where you can go in and define each maneuver, like again, maneuver 1 maybe for a few seconds, and then maneuver 2. And then this is designed to stay on the track, stay at the speed, stay on any braking input or throttle input or gear input that you give. It will obey all of that and effectively follow. And the key thing that comes with that is it implicitly takes into account the state of the vehicle when you transition from one maneuver to another. And that's really one of the big gains from this approach versus having to try to manually capture where is the vehicle state and then continue on. And so this is done by basically just adding that type of advanced driver analysis, and then the main work you do is go in and edit the pretty small and easy to understand file, and then it will run from there. So this one starts out it's a little bit boring, but it starts out at a straight line drive. We can go ahead and run that and just get a look to show you how this driver is integrating with the overall system model. And this just takes a half a minute to run as well.
John, one question here came up. Is in version 14, will there be some training material or tutorial to go over this?
Yes, tutorials, absolutely. As far as training goes, so at Altair we offer a 3-day basic training for MotionView, and it contains automotive examples, but it's really meant to teach the fundamentals of MotionView and MotionSolve environment in the general sense. For the MDL library that we've used so many times in this demonstration, there are a ton of tutorials and lots of documentation. Right now there's not a formal training class for the automotive vertical, but that's actually being discussed right now as how we would present that and make it available, possibly as an online course.
And I think they're mostly concerned about having tutorial available, since a lot of people are kind of remote from Altair offices. So yeah, so in 14.0, which comes out sometime in March, we'll have that in it. Okay.
Yeah. In fact, the previous versions have many tutorials for this, just not the advanced driver. It's just the new feature of the advanced driver in 14, which adds the one more capability, and it has its own tutorials, yes. Okay, so we basically just did a run. I'm going to click on this animate button, and we'll basically watch this start to drive. Again, That one's kind of straightforward because literally it's driving straight, but what it is using that advanced driver for a path controller to keep it perfectly straight, as opposed to the possibility of drifting off to the left or right. But it can, obviously, you can make it a lot more complex than that. So those are some brief introductions to the full vehicle modeling. Now I want to move on to durability, and we're going to start, if you recall, I described two different contexts or types of load generation. There's the semi-analytical and the fully analytical. So let's start out with what we have for the semi-analytical. And again, here you have the library that you can tap into. So I'm going to go back to my model wizard. And in this case, if I build a full vehicle, and the way it's set up is if I basically say I don't have a drive line, then it's going to put in this very simple spring tires. Again, those same defaults. And in this case, since it knows that I have the simple tires, when I go to the analysis, it's going to offer me what's valid. And in this case, it's the 4-post analysis. So let's take a look at what that looks like. All right, so again, when I add the analysis, it puts in all of the necessary topology and some data to be able to run that 4-post analysis. Now, before I run it, there's one other thing I want to do. What are we generally after in this case? Whether it be semi-analytical or fully analytical, we're after loads. Now, there's a really powerful tool in the product that will actually allow you to acquire the loads internal to the system and actually move those over into an OptiStruct input deck for that downstream usage for fatigue type analysis on the component. And to be able to trigger the use of that, what I'm going to go here is add, just individually, I'm going to add a request. And I'm going to say I want a request of force on a body. And I can pick actually all the bodies in the model. But what I'll do in this case is say that we wanted to do something on this arm. So I'll pick that. And what that does, just by adding that request, it causes the output file to have every force that acts on that body. So the front bushing, the rear bushing, the ball joint, the spring, everywhere where a force acts on that body, it's going to record that. It also generates a small side file, we call it a metadata file, which is the key to be able to use that load tool, that load extraction tool. So let me go ahead and run this now. And then we'll take a look at it. And then we'll use that load tool for downstream durability. So the 4-post again is just driving. You can either pick random inputs, or you can have a prescribed. A lot of times what people will do is if they've done spindle acceleration measurements, they'll integrate those twice into a displacement map and feed that in to the 4-post. That's a common thing. So let's take a look at what this guy looks like when it runs. And there you can see, hopefully the frames are coming through the net fast enough, and you can see this overall excitation that's being run on the model. But now, let's say the visualization is one thing, but I actually want to do something with those loads. And that's where, if I go back to the pre-window, there's this utility called load export. And this is a big time saver, because what it does now is I can go and pick that meta file, and it recognizes that in this case I had basically triggered, in this case, one body, and found all the attachments on the body where forces were being generated. And now what I can do is basically grab different time so I can say, well, every single min, pick all of them, and I can do a couple things. I can create a human readable tabular sum in some cases. So I got to give it a little bit of information, and I can modify and give a few things where and then I'm going to export dot dat in a myload subcase. So, and I have all of them. Then the other file is this subcase file. Okay, so that's a brief demonstration of the load an FE solver like OptiStruct to be able to combine that and use like the OptiStruct solution or third-party like ENCODE design life fatigue predictions. So I'm going to get out of that. And now the final thing I want to show you is the durability full vehicle. So in this case, one of the tools that is now available in 14 is the ability to actually build a road. And this, there it goes. And so in this case, there are road profile descriptions that you can get out there on the web, or you can buy them. These are called CRG files. So I'm going to pick this Belgian block one, and I'll keep these defaults. And what this basically does is it creates, well, let me do this first. I'm going to build a full vehicle first so that I can actually have this road that's built automatically come in. So let me just build, say, a full vehicle. I'm going to zip through this with all the defaults just to get a model in the window, because if I do this first and then I go do the road tool, it knows I have a model live that I want to use that road with. So now I'll pick this Belgian block, and what it basically does.
John, with the formats that are out there, you said some other roads, will that be able to import directly into this, or will there have to be some modification to those files?
It imports directly to this, and then this tool here is what converts it into the format the model is most happy with. So it would use those formats for the physics directly, and then it also does a step where it converts it to a graphic format that we use, as you're going to see here in a second, with the model for visualization purposes as well. So I'll give that just a second. Since this is a Belgian block model, there's a lot of nodes and elements.
I'm wondering if the Formula SE teams provide that format for the courses. That would be nice.
Yeah, I think for the Formula SAE teams, depending on the level of durability simulation that they want to do, so for the tracks, those are usually easy to find, like the center line that describes the track and the slope. That would be more for the vehicle dynamics side. And then for durability side, this might be something more that they just pick one from the from the database out there in order to try to get some durability information. All right,
and
so I have the
Baja teams in that case too. Example of something there.
Yeah, right. So the vehicle came in, and basically I can just modify the location of the road and move that, and then be able to run this downstream. But the key point here is that, and I don't have right now. See, the F tire right now is not automatically in the HyperWorks units anymore. So you have to have a CD tire, F tire, or RMOD K tire license to be able to use the 3D tire that goes with the these three-dimensional roads. So I don't have that right here, so I'm not going to run this.
Another question, Shari John. Is the RSP file also a road profile?
Yeah, you can make the RSP as far as whether the format's taken directly or whether you convert it. Generally, it's straightforward to work with any kind of formats. So if you pick the RSP directly, think that can be used direct, but if not, then HyperGraph actually reads an enormous amounts of formats and saves to an enormous amount, like over 50 different formats. And we can use that often to convert from one format to another. But yeah, the RSPs, I believe, are supported fully. So that is, to give a recap, you have a library that allows you to perform automated builds of certain suspension topologies, as well as combining them together for an overall vehicle. You can use traditional analyses of open loop type analyses or lane change, or you can use now the high-end path following brake driver gear system high-end driver and perform these analysis overall. So the idea with the library is to make things as easy to use as possible. Hopefully you saw with the workflow here that it's fairly straightforward. Granted, I was using default models and default data, but as you can see, if the library supports the topology or the topology combination that you're interested in, it's really as simple as modifying data and running with it. If not, then you can always go in and manually modify or even create your own subsystem if you have some very different suspension topology that's not in the library automatically. So I think that concludes the overall brief introduction. There's a lot more that the products can do, both in the pre-processing as well as the post-processing side, but I wasn't going to go over all those in detail.
In this case, this model doesn't match up to the road, that was read in.
Oh yeah. Yeah, there's a couple different things you can do. So here it's a matter of just moving reference marker. So I can go and just pick a different reference marker, and it'll move the road up. And I got to do it with a couple of different pieces there. So, and then they'll also make it at one point where it just snaps in. So that's not a problem. So, and you can move the road around however you would like to. When I did the vehicle road tool, I took all the defaults, but you can stretch it, make it longer, have higher resolution, lower resolution. There's all kinds of control that you can do in here to make that road, let's say, be there for you, in your entire time span that your simulation is going to run, so you don't run off the edge of the cliff kind of thing.
Okay, actually, great. So so this is a good time to see if anybody has any questions for John. So feel free to type into the question window, and I'll relay them to John. And just to let you know, John, we have a pretty well represented audience out there. There's people from looks like APAC, Europe, and of course locally in the US too. So there's a decent cross section out here.
Good.
Okay, so currently I don't see any questions, John. We'll give a couple more minutes, and then I'll jump into, unless there's something else specific you want to show, John, I'll jump into our academia site and how they can get to. Okay, so you cover a lot of material, John. That's a fantastic job. I really appreciate it, and hope everybody feels more comfortable using MotionView and MotionSolve for their kinetics for their vehicle. So seeing no question, John, I am going to change over back to me, and I'm going to cover my part. So thank you so much, John.
Okay, thank you everyone for joining.
All right, just give me 1 second here to get everything set up, and okay, so what I'd like to do here is go into where on our website and show you how you can get access to our academia page, and also where you can find information about our training material and our student edition. So if we just go to our website, it looks like Firefox is being a little unresponsive here. Okay, so in our website, again, no matter what country you're in, you'll see a similar looking website. We do have then our academia tab, and when you go into our academia tab, it will take you to a separate website now for our Altair University, we like to call it. And in this website, it's meant to be self-contained. You find a lot of things here, and this is when you do get the free student version or even the sponsorship version. We do appreciate first trying this, receiving the support here using the support form that's available on this. We have 2 full-time people dedicated to helping out our users, and so they can give give answers to your questions. If they cannot handle the question, they will contact the local office and pass it on to them to help. So first thing is let's say you would like to get the free student version. You just go to software and you go to the free student edition. We do need some information here for you. So we need in this case of valid address to send it to you the information. So email address, you fill it out, your phone number, your contact information, and you'll then get information on how to download the free student version and what information we need to generate a license file for you. So that way, you'll be getting a version just for the workstation you requested for. And the student version is only works with Altair solvers or products. So you can use it with OptiStruct, Radios, MotionSolve, AccuSolve, etc. But it does not interface with other solvers out there. It also for FEA has a model limit. In the current version of 13, it has 10,000 nodes. When version 14 is out, which will be again sometime in March time frame, that will have a 50,000 limit. We have our learning library here, and what this allows you to do is to access available videos and other tutorials, webinars that have been done that go over certain topics. Also, if you notice there, we have archived some of our older stuff there. Those will have a few more training materials that are still like tutorial based, so they're hard copy. And so until those are converted over, they'll be available, so you can access those at this point. And we will be putting on the site here all our tutorials that is provided in our commercial version of HyperWorks. So those will be available soon too. We found that some students want to dive in deeper and get a few and see some additional training materials. So that will be on, be under the, this part here where you go for the free student edition. So that will be available soon for you to be able to get access to those. Then, if you're interested into having Altair sponsor your student team with a free full version, and again, when I mean full version, that means there's no size limits. It can be interfaced with any other software out there, whether it's Abacus, Dyna, Fluent, anything that we have already pre-built interfaces for. You would just go in here, go to sponsorship overview, and in there will be a sponsorship form. You just pick on that link and you'll be able to submit a request. There's not much needed here. The main thing is when you get this license, request it's used, of course, for your competitive needs and not being used for anything else. And we also ask that you put a couple sticker decals on your vehicle. And then besides that, keep us in the loop of how your team does. We've put many, success stories about other competitive teams out there. So you see a picture over here. There's one about the solar car team from U of M, and we've done it for other solar car teams and other Formula SE teams across the globe. So this is a chance for you to get a little bit of advertisement of what you guys have done and to show all the great work that you've accomplished. Then after that, we have our William R. Adam Engineering Excellence Award. This is offered only for the teams that do attend the Formula SE event at Brooklyn, Michigan. And so if you're interested in that, pick on that tab there, fill out the form, and and then during that event, we will meet with your team and judge your vehicle based on what you submitted. And at the end of that event on the Friday, we present a $1,000 award and a $500 award to the top two teams. So those are the main parts of our Altair University. We also have some very nice free books on here that covered some of the main aspects, a lot of the tools that we have available. So we have these are all PDFs. You just pick on them, fill out your information, and you'll be emailed a link to download these books. There's a practical aspects of finite element analysis, one about structural optimization, multibody dynamics. There's a Radios one. And so we have some other books too with FECO and so forth. So some really good books. They're free. I would say take advantage of it. If anything, it'll just enhance your understanding of those topics, even if you are familiar with them. In addition, our goal is to help out universities with getting our tools used more in their curriculum. And so we have underneath here for support and training a way for professors and advisors to contact us, and we'll work with them to embed our tools in their classroom. And we've had a lot of success with some of the teams here locally and also in Europe, but there's hundreds of universities, and we're trying to make a more concentrated effort in helping universities and students out. If there's, those are the main points I wanted to cover. I don't know if anybody has any additional questions. Let me just jump into the question board. I don't see any at this point. And if there aren't any, I'll give a couple minutes to see if anybody has anything to say. But again, we do really appreciate you taking out the time of your busy schedule to see this webinar, and we have two more still about to happen. One will be durability with HyperWorks using OptiStruct, and then we have the last one will be doing crash analysis / impact with Radios. Again, two other great sessions, and if you register for them, you'll get the link sent to you for the any session you register for. We will put these publicly available on our website here too, so just that the people who register get first notification and crack at these. So great, you can let your team members know, and they can also have access to these webinar series events, and then also so they can get access to these videos. So again, I don't see any questions. Again, thank you so much, everybody. Good luck with your competitive vehicles, and I hope we can help you out more in the future. Bye-bye.